Howdy folks, Mr. Reed here, and welcome to one more question. So what we're going to be taking a look at today is multiplying two binomials together, and this is going to be kind of a mild level of question. However, I'm going to do some introduction as to why this is even possible in the first place. So if multiplying binomials is what you want to get into, you're in the right place. Let's get to it. Alright, so the binomials that I have up above, and if you're not sure what a binomial is, it's a two-term algebraic expression. Term is kind of a little bit wishy-washy, but for us, what I'm going to simplify that to is just things that are split with addition or subtraction symbols in between them. So if you've got a group of stuff that's all multiplied together, that's just a single term still. So up above, the x is a term and the 1 is a term in the first bracket, as well as the x is a term and the 3 is a term in the second bracket, which means I have two binomials, so two term expressions. Each one of those brackets is a binomial. So before I get into how we're going to do that, I want to talk about multiplying. So this is going to seem a little weird at first, but stick with me. So if I took the number 4 and I multiplied it by the number 5. Somewhere along the way, most of you either are pretty comfortable with some arithmetic facts. It depends on whether I'm doing sequences in series, but that's another thing altogether. So if some arithmetic facts, 4 times 5 is equal to 20, where you pull out your calculator, whatever you're most comfortable with, and yes, there we go. We can multiply. You probably also are comfortable with the fact that if I make a little rectangle that looks like this, and I said that this side length is 4 and this side length is 5, and even if I split that up into 1, 2, 3, 4 pieces going up and down, and I went 1, 2, 3, 4, 5 going in that direction, the cuts, then I could say 4 times 5, we could talk about like an area, so 4 times 5 is 20. In this particular case, I could also count boxes. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We would get that same 20. And so I can represent the multiplication of 4 times 5 with this little rectangle, and that gives me the same thing. What if I didn't know one of the sides of this rectangle? So what if one of the sides here was x and the other side was 5, but x represented some number that I don't know? It would still be true that I could multiply x times 5 together, and what we're going to say that is going to be equal to 5 times x, which we just represent as 5x usually without a multiplication symbol in between them. But that could be represented with this kind of box idea as well. So we don't know how many ways we're splitting it up like this, but we do know it will be 1, 2, 3, 4, 5 in the kind of horizontal cuts that I make there. So I would know that there's x, however many that is, times 5 of these little boxes that are made. Now, if you follow with me for that, then I'm going to make a new box here, and I'm going to say that it is x plus 1 is the length of it. So it's some variable, but it's also 1 larger than whatever that variable ends up being. So if x ended up being 5, then the length of this side would end up being 6. If it was that was a 7, well, the length would be, if the x was a 7, then the length there would be an 8. So that's kind of how we can say what x plus 1 means in this case. What if I were to multiply that by x plus 3? So this should look a little bit familiar because it's what's going on up there. Now, this is x number of splits this way. So 1, 2, 3, 4, I don't know how many, plus 1. So there is a 1 unit at the end with some unknown part at the beginning. So I could split them all up into individual pieces, but I don't really have to do that. What I could do instead is say that it's x, however many that is, plus 1. So this little part right here, if I just change the colors, that would be x, and then I would have a second part next to it that would be 1 in terms of the length. So it is x plus 1. Going down the other way, I would also have x as the length here, but I would have 3 as the length of the other part there. So this part down here is actually a new length of 3. So this one's a 3, this one is a 1, these two ones are x's. So now when we work out what the size of this new thing is that we multiply, or multiply our two sides to get the area there, well, that's kind of hard because I don't know what x is. But if we pay really close attention to what's going on here, we could say that this part right here, that is actually, I know that the side here is an x because it comes from this one over here, and this side up here is also an x. So what is it? Well, it's x times x. Something by times itself is the square of it, so that would actually have a size of x squared. The one down at the bottom is 3 units this way because it's the same size as this one over here on the right, but it's also x units this way. And so what's 3 times x? Like we said before, if you multiply a number by x there, it just becomes 3x in this case. So I have 3x for this little piece here. Next up, I have a new rectangle right here, and that one is 1 by x. So it's 1 times x, which is 1x. Most of the time, we're just going to write 1x as being x. So we don't write the 1 in there as a coefficient or a multiplying number on the front. We would just write in x. And for the last little rectangle that's down here that I haven't taken care of yet, that is going to be 1 and 3 as the side lengths there. So 1 times 3 would be 3 in that spot. So I have the area of each of these 4 little rectangles that are making up my larger one. I have x squared for the first one. I have a single x for the one in the top right. I have 3x for the one in the bottom left. And I have 3 as my last one there in the bottom right. So the total area here would be those 4 pieces all together. So it would be x squared plus x plus 3x plus 3. And so there are no other x squareds, so that just ends as being x squared. There are 1x, 1 apple, and 3 x's, 3 apples. So 1 apple and 3 apples is 4 apples. 1x and 3 x's is 4 x's. So we would get 4x there. And then the 3, that's just a number, is the only just number part of this. So we would get x squared plus 4x plus 3. Now well, I shouldn't say that because some people feel comfortable with that. But personally, I wouldn't want to have to draw a rectangle every time I want to do this multiplication. So instead, what I would suggest is if I write down the original multiplication statement, which is x plus 1 in a bracket multiplied by x plus 3 in a bracket. I'm going to teach you the general way of looking at this only algebraically, so only with the letters, no diagram to go by to kind of pair this thing up with. You take everything that is its own term in the first bracket and multiply it separately by everything that is its own term in the second bracket. So the x in the first bracket will multiply with both the x and the 3 in the second bracket. So that would be x times x is x squared. X times 3 is 3x. You would also get the other term in the first bracket, which is a 1, multiplied by the first term, which is the x in the second bracket. That would give us x. And also we would multiply it by the second term in the second bracket. So 1 times 3 is 3. We would take all these results, add them all together, and we'll end up getting x squared plus 4x plus 3. Now, the neat thing is that this works for binomials, But if you go with the rule that every single term in the first bracket multiplies every single term in the second bracket, then you can actually put any number of terms in those two brackets, so just the two bracket setup, and you can follow that same rule. So every single term in the first bracket multiplies every single term in the second bracket. So I'm going to do another example of this sort of thing in my next video, but you want to feel pretty comfortable with this first. So I would probably suggest finding some practice material for doing the multiplication of binomials. If you don't really like what's going on with the stuff that I did earlier of making rectangles and trying to compare it, I'm just trying to come up with some justification that what I'm doing with what ends up being like a distributive property for binomials, that every single one of those terms in the first bracket is going to multiply by every single term in the second bracket. Well, that gives you the same thing that as if I had broken this up into two pieces, x and 1 along the top for a length, and then x and then 3 along the side, and then try to find the area of that particular rectangle. If you split those rectangles up into x and plus y plus 5, it actually still works. So the number of different terms that are there don't matter, which is pretty exciting, pretty cool. But I'm going to leave it at that for the time being. So if we want to multiply the binomial x plus 1 with the binomial x plus 3, we can just say multiply all the terms in the first one with all the terms in the second one, add together all the results, and in the end, simplify things that you can, and that's going to be our answer. So in this case, that answer was x squared plus 4x plus 3. Okay, if you found that one helpful, like, subscribe, and as always, take care, folks.